My name is Presley Garrison, and we are in the Clinical Center in Building 10 at the NIH. This lab focuses on pediatric endocrinology, specifically growth abnormalities in kids, either growing too small or growing too big or growing weirdly, just generally. I'm from North Carolina. My mom is a nurse, and she has a PhD in nursing, so she does public health research related to nursing. My dad is a forester. And I always sort of wanted to be in science. I studied biochem in college, but before that I went for high school in North Carolina called the North Carolina School of Science and Mathematics, and was really into chemistry and thought I wanted to be a chemist. And then it just so happened that I really liked being around patients and people, and I think I want to be more involved in clinical work now, so I'm in medical school. Being a selected scholar for the medical student research program at the NIH is fantastic. So I'm right in the middle of my second and third years of medical school. I get to take a step back from medical school, which is very intense, and think about what I want my career to look like. And I get to spend time with people who have fantastic careers and learn about what that looks like and how they got there. And it's a really unique opportunity, and I'm super lucky to be here. So we are interested in what goes wrong in the growth plate. And the growth plate controls the development of long bones like the tibia or the femur. And so if something is going wrong, presumably the way that the DNA expresses itself will change. Okay. And so we're kind of looking at like what expression is happening in the DNA in the growth plate. We dissect out the growth plate and then make sections of the growth plate so that we can take little pieces of it and then extract RNA from the very little pieces of it. It's actually just like a laser controlled by a computer. So I just sit at a computer physically and I draw out a section on the growth plate tissue that's under a big microscope, and that tells the laser where to cut. And so the section I've drawn out is like the hypertrophic zone of the growth plate, and those are like the big cells, and I can tell that that's the hypertrophic zone. So I draw it out, and then the laser cuts it, and also has a different type of laser that will like kind of glue it to a new slide. Right. And so then you glue it away, and then it's all on this like little cap. It looks like this. And then you put it in like 42 degrees for 30 minutes, and then you just have RNA. And then you have to clean up the RNA so that you can see what it is. And so then I go over here to this bench and I do the RNA extraction. And then we take the RNA and count it with little probes, and that's called nanostring, and that's how we know what RNAs are being expressed. I think we'll have a lot more sequencing for the general population in 15 years' time. And so I think we'll have people that have growth abnormalities today that we call idiopathic, which means that we don't know why they have them. And I think there will be a lot less of that, where we have an explanation and we have something we can do about it. I'm only a medical student. I don't have like formal research training, and so I'm really lucky to be able to spend this year at the NIH with people who have PhDs and postdocs and MDs and just a lot of like previous research experience. So I have a postdoc in the lab that I work with really closely who has helped me through the way and helped me think about how my project is going to go and taught me how to do experiments, and that's been really helpful. But outside of that, we collaborate with a lot of different labs. When we don't know how to do something in this lab, there's someone at the NIH generally that does, and so that's always really exciting. There are very few limitations because we always say, oh, someone here is doing that. This is an amazing job because I get to be creative, I get to be around people who are creative, and usually these creative ideas or solutions end up helping a huge number of people. So doctors will see patients that have a problem and they'll say to themselves, what can I try in the lab setting, or what can I try on a couple of patients that can tell me about tons and tons of patients who have this problem and we didn't previously know how to do something that's this helpful. So it's just it's a very cool environment.